Today we are going to study a topic from ninth grade science subject from the chapter Gravitation. Okay.
Yes,
Have
ma'am.
you all gone to the swimming pool and have swimmed and all? Have you done that?
ಇಲ್ಲ ಮ್ಯಾಮ್ ಮುಳುಗ್ಬಿಡ್ತೀವ್ರಿ ನೀರಾಗ.
Okay, you have not gone to the swimming pool. Then have you ever pulled water from the well in a bucket?
Yes, ma'am. We have.
You have done that?
No, ma'am. ನಮ್ಮ ಮನ್ಯಾಗ ಬಾವಿನ ತಗ್ಸಿಲ್ರಿ.
Exactly. I have also not done that, because our parents and they used to do what I used to do. I used to take a bucket like this and keep it in the ground floor. I used to keep it in the ground floor and I used to go upstairs in the first floor. And I used to take a mug or something like that and I used to tie a rope to that. And I used to leave it from the first floor and used to pull the water from this bucket and used to play like I'm taking out the water from the well. Have you all done this in your childhood? If not, you have used the well. You might have done this imitation game in your childhood.
Yes, ma'am.
You have done it. Maybe boys have not done it, but girls might have done it, haven't you?
Yes, ma'am.
Okay. So Another question is, every day you go to shower and you go to bath, no? That time you will be having a full bucket water. That time you will be immersing your mug in that. That time the water sometimes spills outside of the bucket, right? It does happen, right? Usually.
Yes,
Sometimes it
ma'am.
spills out of the. Why it all happens? Do you know that? Why all these things happen when you pull the water out of the well, when the bucket or something that is immersed in the water, that bucket seems very light, but when you pull it out of the water, it suddenly becomes heavy to your hand, right?
Yes, ma'am.
Why that happens? Do you have any idea why it happens? No idea. At least say yes or no. Do you know that or not? Or
No,
you don't know
no,
that?
ma'am.
You don't know that? Okay. So I'm going to show you one demonstration here. I have taken a bucket or something like a dabba full of water. I have colored it green because you should see in the camera, right? If I put it colorless, you will not see what I'm going to demonstrate. So I have made it green. Now I'm going to take a water bottle which is empty. It's not actually empty, it has air in it. A water bottle filled with air. I will try to put this in this water. Do you see the rise in the water level? Can you see that?
Yes, ma'am. Yes, ma'am.
But while I'm immersing here, if you have, I told you about that mug in the bathroom. That one I told you, no, when you go to the bathroom, when you go for the showering and all that, and when that happens, you will feel the pressure on your hand while you are immersing a air-filled bottle inside. Do you feel that? Have you experienced that?
Yes, ma'am.
Right. See, I'm trying to immerse it inside, but the water bottle is not going inside totally. The moment I leave it, it's coming outside. Why is it happening? What is actually happening here? The moment I leave it, it's coming outside. Right? We know the gravitation power, right? The moment I leave this bottle down, it will go down. But the very thing when I'm doing it inside the water, inside the fluid, it is not happening. Do you think the gravitation force doesn't act in the water? Gravitation force acts in the water or not? Gravitation
Yes, ma'am.
force, gravitation force is present in all three mediums. Actually, it is present in all three mediums. But the only difference why this happens is the bottle has its own weight, right? The bottle has its own weight, but the weight of the bottle is less than the weight of the water, right? Density of the water. So what happens when you immerse this empty bottle, the water filled with air, the gravitation force is downwards, but there is another force that is in the upward direction. That is pushing the bottle in the upward direction. This force, what we call it as? We call this force as, I'm going to write it down, upthrust force. This upthrust force is also called as Buoyant force. So, our topic today is the study of this phenomena where the upward thrust and the buoyant force act on the object immersed in the bottle. And the topic name is Buoyancy and Archimedes principle. Have you heard about the scientist named as Archimedes? Have you heard about him? You
Yes.
might have heard a story about an Archimedes, a scientist named Archimedes. It is a very common story you have heard. Once what happened, this Archimedes scientist was there, no? He had to find out some factor about the purity of gold in his kingdom or something like that. The king had ordered him to find out the purity of the gold, how to find it out. So he was thinking, how should I calculate the purity of the gold? How I should be calculating about the purity of the gold? He was thinking and he was thinking. He was not getting it all. One day he went to the shower and he just filled his bathtub with the water. He just filled the bathtub with the water and he got into the bathtub thinking about what to do. Like that he went. When he got into the bathtub, immediately the water spilled outside the bathtub. The moment the water spilled outside of the bathtub, he suddenly stood up and started screaming like Eureka, Eureka, Eureka. Meaning that Eureka means what? I have got it. I have got the answer. I have got the answer. And he started running all around the street. You have heard about this story, right? You have heard about this story? You have not heard about this story? Students, are you there? Insera?
Yes, ma'am.
Yes. In this story, this person, the Archimedes is the person who discovered, not invented, who discovered the concept of buoyancy, and he made a Archimedes principle. Okay, today we are going to study the topic buoyancy and Archimedes principle. Okay. Now, I am going to take another beaker filled with water here. Can you see it in the camera? There is an orange water, right? Can you see it? Is it visible to you?
Yes, ma'am.
Okay. Here, I'm going to do something now. Here, I will put, can you see the snail?
Yes, ma'am.
Yeah, I will put this nail inside this. What did happen? The nail got immersed in it, right? It sank down.
Yes, ma'am.
Yes, ma'am.
And now I'm going to take a some small wooden piece and I'm going to put it in this water. What is happening here now?
It's floating, ma'am.
It is floating. Nail sinked in the water, but the wooden piece is floating in the water. But both of this nail and this wooden plank, both are of the same weight actually. This is also of the same weight and this is also of the same weight. But the nail sinked in the water and the wooden piece floated in the water. Why is this difference happening? Why did the wooden piece didn't sink in the water and why didn't that nail float on the water? Do you know that? Because of the upthrust force and the buoyant force. The concept we are studying right now, that is the reason for that. what happens? The density of the wooden piece is less than the density of the water. There are several kinds of liquids, right? Water is one kind of a liquid, oil is one kind of liquid, and milk is one kind of liquid. But milk's density is different, water's density is different, and oil's density is different. When you consider, when you compare the density of this wooden piece to the density of water is more than the density of the wooden piece. So in water, the wooden piece floats; it doesn't sink. But when you consider the same thing, the iron nail, the density of this iron nail is more than the density of water. So the same nail, the nail which is of the same weight as of the wooden piece, it sinks in the water. And there is another thing. Have you all wondered? You might have wondered when you go to the beaches and all the places, you see so many big shape and small shape, and all those shapes. They are floating above the sea. They are so small. They are made of the iron, but they are not sinking. They are not drowning in the water. But instead, they are floating above the water. Why is that happening? Why is that happening? It is a metal piece, right? Just like this nail. A nail is a metal piece. It has a higher density, but still, that ship is not sinking. But the same amount of metal, it is in a shape of a box or something, it will sink. Do you know why that happens? Why there is a difference? So here I will show you another piece here. The same demonstration. You are seeing this butler, right? It is a metal butler. That I am going to place it on this water. It is not sinking, it is floating in the water. I am going to take the same weight, same metal. I am going to take a same metal piece which is of a different shape like this, something solid shape. I will place it in here, but it will sink inside the water. What is the difference between that? Both are same metal and both are of the same weight, but still one is floating and one is sinking. Why is that happening? Why is that happening? That is happening because this shape is not a container shape, okay? But this one is of the container shape. The weight of this container shaped metal might be same to this, but because it is having a container shape, it will be occupying the volume here. The inside of the container, what it will be occupying? The air volume. So the density of this one will get reduced. It will get lesser than the water. How it will happen? Because it is not just about this metal, what it is made up of. It is not just about that now. When it takes the container shape, it is also due to the air present inside here. This whole volume is considered, and the air and this whole together, this density will be less than the density of water. But here it is not of any container shape. It is not of anything such. So it is will not hold any air or something. It will just pass by and it will just drown inside the water. That is why this is the reason the buoyant force and the phenomena of buoyancy is the reason why these ships and all, despite being of the heavy weight and despite being of the heavy density metals, they will not sink in the water, but instead they will float over the water. Okay. Now, with this, we understood why the density, how the density works, the mass per unit area. Density is equals to mass per unit area. How the density is connected to the sinking and floating of the objects in the water. Now, we will study what exactly the Archimedes principle is. What did he actually postulate? What did he actually state? What do you see here? What I am holding here? What I am holding in my hand? Can you see a stone here?
A stone, ma'am.
Stone is tied to what? A thread. right? Can you see
Yes,
it?
ma'am.
Okay, I will bring it closer to
Yes,
you.
ma'am.
Yes, and the thread is connected to what? What is it connected to? Can you see it? A spring. Can you see a spring here?
Yes, ma'am.
Yes. There is a stone which is tied up to a string, and that string is connected to the spring. That spring, do you see a, just I will hold it. It is of this way. When I leave it, it will be little bit elongated. Now the same spring, I will try to immerse this stone inside the water. The moment, just observe what happens the moment this stone touches the surface of the water, and when it starts to immerse the water, observe what happens. Did you see that the spring which was a little bit elongated this way, the moment it touched the surface it became like this, it just compressed a little bit. What does that suggest? What does that suggest? That means when when a stone or when an object is immersed in a water, that stone will displace the volume of water, which will be resulting into the rise of the water level. The water level was at one level. When the stone was immersed, the water level increased. What happens there? What exactly happens? That water which was on the surface, no, that water got a little bit displaced. It went this way, something like that. I will show you here. The water was on this level. When the moment the stone immersed, the water got displaced like this. When this water got the water from here got displaced like this, when it happens like that, that water which is below the stone which got displaced, that exerts the upward force on the object, and the amount of can you measure by this? We all discussed about the beyond force and the upward thrust and all that, but every force has the magnitude, right? Obviously we are talking about the vector, it is in the upward direction, that is the vector, but that force is having some magnitude. How can you know that? Does the stone, every object that goes immersed in the water, experience the same amount of the force? No, right? This stone with certain weight experience a different amount of the force, and this one with a different thing, different weight, it will experience a different amount of force. Why that happens? What exactly is the difference between the two forces, two kind of buoyant forces? The difference is the weight of the stone, the weight of the stone, the mass of the stone, the exact mass of the stone, whatever it is, that much of the volume, that much of the volume of the water is displaced from the actual water body. The amount of the what Archimedes principle states is the magnitude of the buoyant force depends on the amount of water displaced from the liquid body. Did you understand? Did you understand the concept of what is the buoyant force, phenomenon of buoyancy, and the Archimedes principle? Is the concept clear to you, children?
Inshara, Vijay, Omkar. Yes, ma'am.
Yes, okay. Now I will ask you questions about the topic we studied. Will you answer?
Yes, ma'am.
Yes. The question
Yes, ma'am.
is, when we immerse a water inside, when we immerse an object inside the water, the upward thrust, what you feel, what is it called as? What is the name of that force?
Buoyant force.
Yes, beyond force. Okay. Thank you, everyone.
Thank you, ma'am.
Any feedbacks?
ಎಸ್ ಇಂಚನ
Ma'am.
ಈಗ ಎಷ್ಟು ಸ್ಟೂಡೆಂಟ್ಸ್ ಕಂಪ್ಲೀಟ್ ಮಾಡಿದ್ರು?
ಮ್ಯಾಮ್ ಇವಾಗ 7 ಮೆಂಬರ್ಸ್ ಆದ್ರಿ, ಇವಾಗ ನಾ ಲಾಸ್ಟ್ ರೀ.
ಓಕೆ ಫೈನ್. ಹೇಳಿ ಫೀಡ್ಬ್ಯಾಕ್ ಅಬೌಟ್ ಚೈತ್ರಾಸ್ ಲೆಸನ್.
The way she presented is very excellent, ma'am, and she also did some demonstrations, and she used the inductive and
ಎಸ್
deductive method.
ಮಾಸ್ಟರಿ ಓವರ್ ದ ಕಂಟೆಂಟ್.
Ma'am, your voice is not audible now.
Hello.
ಎಸ್ ಎನಿ ಅದರ್ ಸ್ಟೂಡೆಂಟ್ಸ್? ವಿಜಯ್ ಆರ್ ಓಂಕಾರ್,
Yes,
ಶಾಯಿಂತಾಜ್,
ma'am.
ಎನಿ?
Yes, ma'am.
ಹಾ ಹೇಳ್ತೀರಾ, ಫೀಡ್ಬ್ಯಾಕ್ ಹೇಳ್ತೀರಾ? ಹಾ
Yes,
ಹೇಳಿ.
ma'am. She used all of the skills, ma'am, with demonstration and all, and the
ಹಾ
explanation was excellent.
ಓಕೆ
Overall, it was very good.
ಓಕೆ
Excellent presentation.
ಓಕೆ ವೆರಿ ಗುಡ್ ಚೈತ್ರ.
Okay.
ಲಾಸ್ಟ್ ಸ್ಕಿಲ್ ಅಲ್ಲಿ ಕೂಡ ಐ ಹ್ಯಾವ್ ಅಬ್ಸರ್ವ್ಡ್. ಓಕೆ ಗುಡ್, ಎಕ್ಸಲೆಂಟ್ ಪ್ರೆಸೆಂಟೇಶನ್, ನೋ ಡೌಟ್. ಒನ್ ಒನ್ಸ್ ಇನ್ ಫ್ಯೂಚರ್, once in a fine day it will come. You will become a good excellent teacher in future.
Thank you, ma'am.
ಓಕೆ ಗುಡ್ ಬಿಕಾಸ್ ಆ ಸ್ಕಿಲ್ ಎಲ್ಲ ತುಂಬಾ ಚೆನ್ನಾಗಿ ಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀರಾ. ನಿಮ್ಗೆ ಬಿಕಾಸ್ ಕ್ರಿಯೇಟಿವಿಟಿ ಆಫ್ ಟೀಚಿಂಗ್ ಗೊತ್ತಿದೆ ನಿಮ್ಗೆ, ಯಾವ ತರ ಮಾಡ್ಬೋದು ಅಂತ ಹೇಳಿ. ಸೊ ಎಕ್ಸಲೆಂಟ್ ಪ್ರೆಸೆಂಟೇಶನ್, ಗುಡ್, ಕೀಪ್ ಇಟ್ ಅಪ್. ಓಕೆ
Thank you, ma'am.
ಓಕೆ ಫೈನ್. ನೆಕ್ಸ್ಟ್ ಹೂ ಇಸ್ ನೆಕ್ಸ್ಟ್? ಇಂಚರ.
Yes, ma'am.
ಓಕೆ ಯು ಕ್ಯಾನ್ ಸ್ಟಾರ್ಟ್ ಮಾ.
Yes,
ಉಳ್ದವರೆಲ್ಲ ಚೆನ್ನಾಗಿ ಮಾಡಿದ್ರಾ ಪಾಠ? ನಾನು ನೋಡಿದೀನಿ, ಬಿಕಾಸ್ ಲಾಸ್ಟ್ ಎಲ್ಲ ಫಸ್ಟ್ ಸ್ಕಿಲ್ ಟು ನಿಮ್ಮ ಯಾವ್ದು ಸ್ಕಿಲ್ಲಿಗೆ ನಾನು ಜಾಯ್ನ್ ಆಗಿದ್ದೆ? ಮೇ ಬಿ ಕ್ವಶನಿಂಗ್ ಸ್ಕಿಲ್ ಅಲ್ಲ, ಆರ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಸ್ಕಿಲ್. ಎಸ್
ಎಲ್ಲಾರ್ದು ಮಸ್ತ್ ಆತ್ ma'am.
ಕರೆಕ್ಟ್. ಹೌದು ಎಲ್ಲರೂ ಚೆನ್ನಾಗಿದೆ. ಈ ಟೀಮ್ ಅಲ್ಲಿ ನೀವೇನಿದ್ದೀರಾ ಎಲ್ಲರೂ ಚೆನ್ನಾಗಿ ಮಾಡ್ತೀರಾ. ಐ ಹ್ಯಾವ್ ಅಬ್ಸರ್ವ್ಡ್ ಇನ್ ದ ಲಾಸ್ಟ್ ಸ್ಕಿಲ್. ಓಕೆ ಗುಡ್. ನನಗೆ ಸ್ವಲ್ಪ ವ್ಯಾಕ್ಸಿನ್ ಅಲ್ಲೆಲ್ಲ ಕಾಲೇಜಲ್ಲಿ ಸ್ವಲ್ಪ ವರ್ಕ್ ಇರೋದ್ರಿಂದ ಹೋಗಿದ್ದಕ್ಕೆ ಬಿಫೋರ್ ಎಷ್ಟು 4 ಮೆಂಬರ್ಸ್ ಮಾಡಿದ್ದೀರಾ ಪಾಠ, ಅಬ್ಸರ್ವ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗ್ಲಿಲ್ಲ. ಬಟ್ ನಾನು ಐ ಆಮ್ ಡ್ಯಾಮ್ ಶ್ಯೂರ್ ನೋಡಿದ್ದೀನಿ ಲಾಸ್ಟ್ ಸ್ಕಿಲ್ ನೀವು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡುವಾಗ ತುಂಬಾ ಚೆನ್ನಾಗಿ ಮಾಡಿದ್ದೀರಾ. ಸೊ ಏನು ಅಂತಾರಲ್ಲ, ಅನ್ನ ಬೆಂದಿದೆಯೋ ಅಂತ ನೋಡೋದಕ್ಕೆ ಒಂದು ಇದು ಸಾಕು ಅಂತ. ಹಾಗಾಗಿ ಲಾಸ್ಟ್ ವೀಕ್ ಅಲ್ಲಿ ನಾನೇನ್ ನಿಮ್ಮ ಸ್ಕಿಲ್ ಅಬ್ಸರ್ವೇಷನ್ ಮಾಡಿ, ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಎಸ್ಪೆಷಲಿ ಅವತ್ತೇ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಸ್ಕಿಲ್ಲೇ ನಾನು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ದು. ಸೊ ಎಲ್ಲರೂ ಚೆನ್ನಾಗಿ ಮಾಡಿದ್ದೀರಾ, ಹಾಗಾಗಿ ಆ ಹೋಪ್ ಇದೆ ನನಗೆ. ಓಕೆ ಫೈನ್, ಅದನ್ನ ಕಂಟಿನ್ಯೂ ಮಾಡಿ. ಇನ್ನು ಫ್ಯೂಚರ್ ಇನ್ನೂ ಚೆನ್ನಾಗಿ ಮಾಡೋದಕ್ಕೆ ಟ್ರೈ ಮಾಡಿ. ಓಕೆ.